Alright, so this is the homework sheet for complex zeros. I'm going to do questions 1 through 6 with you if you want to do your homework with me. So for question number 1, the question is just find all the zeros. And that the fundamental theorem of algebra says the degree tells you how many zeros there are. So I'm looking for 4 zeros. So I'm first looking to see if I can factor it. It's a simple trinomial. So I'm looking at negative 80 and I'm looking at negative 11. So I need to go through my times tables. It's not 20 times 4 or 8 times 10 because they don't subtract to 11. So it's one of the other ones that's not as obvious. So I'm going to help you through it. The two numbers that multiply to negative 80 and add to negative 11 are negative 16 and 5. So they work. So I'm going to come back here and I'm going to make sure I use x squared, take away 16, and x squared plus 5. So for each factor, I'm going to make it equal to 0 and solve it. So that when I take the square root and solve it, one answer is positive and negative 4. Those are real and rational. X squared plus 5, when I subtract 5, I realize I'm going to have to take the square root of a negative number, and the square root of a negative number is imaginary. So the answer is positive or negative, but it's imaginary, and then the root 5. And that's it. Those and those are your zeros. And we found 4 of them. Number 2, what makes this powerful is if you choose to do your best and then watch the video. Or if you don't know how to start it, I start it for you, and then when you get comfortable, you finish it and then play the rest of the video. So it supports you and you're not just copying what I'm doing. So again, a trinomial. 4 times 12 is 48 and 49. So that's simple enough what two numbers I'm going to use that multiply to 48 and add to 49. So I'm going to take out the 49x squared and put in 48x squared and 1x squared. And then I'm going to factor by grouping. So I'm going to take out a 4x squared. And that leaves me with 12, just 1, and that leaves me with 12. So they share a common factor, and what's left over is that. So each one I'm going to make equal to 0. So again, whenever you're comfortable, press pause and finish it. And hopefully the next one you can start without me. So for this one, I'm going to subtract 12. Then, when I take the square root, I know the answer is positive and negative. The square root of a negative number is imaginary. Now the square root of 12 is 4 times 3. So the square root of 4 is 2, and what's left over is 3. For the second one, I'm going to subtract 1 and then divide by 4. When I take the square root here, again the answer is positive or negative. The square root of a negative number is imaginary, so it needs a I. And the square root of 1 and the square root of 4 leaves me with positive and negative 1/2 I. Again, all 4 zeros are complex, but all 4 numbers, if you plugged it in, would give you the answer 0. If you would graph this, there'd be no real x-intercept. So it wouldn't cross the x-axis. But if you plug these numbers in, it would give you the answer 0. All right, number 3. All right, let's see how we can factor it. So I see 4 terms. So the first thing I'm going to try to do is take out a common factor. So the first 2 terms, the common factor is x squared. The next 2, the biggest number that goes into 54 and 36. That'd be 18. That's a big number. And that's 3x take away 2. Wonderful. They match. So this is factorable. They both share the factor 3x take away 2, and what's left over is x squared plus 18. So if I take 3x take away 2, or x squared plus 18, I can now solve it. So for this one, I'm going to add 2 and divide by 3. For this one, I'm going to subtract 18. So I know the answer when I take the square root is going to be positive and negative. I know that there's an I a part of it because it's the square root of a negative number. 18 is 9 times 2. So the square root of 9 is 3, and what's left over is 2. And there they are. There and there are all three zeros of that function. Again, I got 4 terms, so I'm hoping I can factor by grouping. Oops, 27. It's at 27. So negative 27. So that leaves me with positive x, take away 1. So I have x subtract 1 and then x cubed subtract 27. Now, this is called the difference of cubes. You know the cube root of each one. So I'm going to do synthetic division with 1, 0, 0, negative 27. And the cube root of 27 is 3. So I'm going to use 3. 3 times 3 times 3. And I'm going to use the cube root of that number and divide. And you can see the remainder is 0. Now, what's left over? So far I've found that 3 is a 0. If I take x subtract 1, I also found that 1 is a 0. So now I got 2 answers. To find the last one, I have x squared plus 3x plus 9. So it's simple, trinomial, but with an odd number for b, I'm going to use the quadratic formula. So the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. And then I'm going to simplify it. So again, negative b plus or minus the square root of b squared, so 3 squared is 9. Take away 4ac all over 2a. So if I reduce this down, I get 9 take away 36 over 2. So 9 take away 36 is negative 27. So it's negative 27. So let me just finish it off right here. So the square root of a negative number is imaginary. 27 is 9 times 3. So square root of 9 is 3, and what's left over is 3. And then the denominator is 2. So 2 complex zeros there. Negative 3 plus or minus 3i root 3 over 2 and 1. And 3. So 1, 3, and 2 complex zeros. 4 in total. And the degree is 4. All right, you try number 5. You've practiced enough. Press pause. Number 5. All right, my turn. Factor out an x to the 4th, and you have 2x plus 1. Factor out a negative 16, and you have 2x plus 1. They share the factor, 2x plus 1, and what's left over is x to the 4th take away 16. Now, x to the 4th take away 16 is a difference of squares. So the square root of x to the 4th is x squared, and the square root of 16 is 4. So it's x squared plus 4, x squared, subtract 4. One more time. X squared plus 4 is prime. X squared take away 4, again, is a difference of squares. So the square root of both, so the square root of x squared and the square root of 4 makes it x plus 2 and x take away 2. So each one of these is going to give me zeros. Remember, I'm looking for 5 zeros. So already I know that negative 1/2, right? Negative 1 divided by 2. Positive and negative 2. So I have 3 rational answers. Now how do I find the last one? Take x squared plus 4 equal to 0 and solve it. And the answer is positive and negative 2i. So the square root of 4 is 2, but it's I imaginary because you've taken the square root of a negative number. So there are all 5. Negative 1/2, positive and negative 2, positive and negative 2i. All the numbers that make that function 0. That's rational and real and imaginary. All right, number 6. You, then me. So press pause, do your best, then press play. So they have a common factor, 3x cubed. That leaves me with 5x plus 2. Here, factor out a negative 5, and I'm left with, wait a second, 15. 5 does not go into 6. 3, silliness. Factor out a negative 3, and you get 5x plus 2. I knew they'd have to match. Felt pretty good about that. So they share the factor of 5x plus 2, and we have 3x cubed, take away 3, left over. Now, if I take each one, so if I take 5x plus 2 equal to 0, you can solve that. Subtract 2 and divide by 5. Take the next one. 3x cubed, subtract 3 equal to 0. Well, the first thing I notice is that I can reduce it down by dividing everything by 3. So it's really x cubed, subtract 1 equals 0. This is called the difference of cubes. So I don't want to solve for x cubed because I'm going to miss an answer. But if I do that, right in terms of it. So x cubed equals, or x cubed subtract 1 equals 0. So one answer I can do by number sense even. If I plug in positive 1, the answer is 0. So I'm going to use that fact. So I'm going to do synthetic division, and it's going to be 1, 0, 0, negative 1. And I just said positive 1 is definitely going to work. So with my number sense, I can see that positive 1 is going to work. So already I found negative 2 over 5 and positive 1. Then, what's left over, x squared plus x plus 1, I'm going to use the quadratic formula. So the quadratic formula is negative b plus or minus b squared minus 4ac all over 2a. So we have negative 1 plus or minus the square root of. Now 1 take away 4 is negative 3 over 2. So we know the square root of a negative number is imaginary, but root 3 can't be reduced down. So negative 1 plus or minus I, root 3, all over 2. And the other 0 is negative 2 over 5, and the other 0 was 1. So negative 2 over 5, 1, and 2 complex answers. There it is. You practiced, and now you're ready for the quiz. Good job. I'm proud of you. Mr. G Math, over and out.